our next session and next speaker, who is Warren. Where we will be talking specifically about optimizing the battery efficiency and maximizing the lifetime of batteries with Mr. Warren Lazarus. Warren, are you with us?
Hi, everybody.
Yes, hello, welcome. Before I hand over
Yeah,
to you, Warren, I'll do a quick word of introduction. You are a
perfect.
project manager at the company Freedom one of the leading manufacturers of battery products in Africa, based in South Africa. You've been a project manager there since last year. But before that, you've built up almost 10 years of experience in electronic engineering and renewables, among others, working with companies like CBI Electric, Knorr-Bremse, and Eskom, the national utility company in South Africa. And you have a educational background in electrical and electronics engineering from the University of KwaZulu-Natal. We're very pleased to have you with us today. Um,
Thank you for that, John. Yeah,
sure, I mean, we are growing into the demand and the specificities of storage. And the topic that you will be addressing now is definitely one of the key topics, burning questions that our listeners have. So without further ado, I hand over to you. You may share your presentation and get started.
perfect. Let me just share my presentation. Uh, 1 second.
Yes, no worries. I'll just let you know once we start seeing your screen.
Yeah, it just says host disabled participant screen sharing. So if you could just let me.
Absolutely my bad. I'm a very bad host. Sorry about it. There you go.
Perfect. Just let me know when you can see my screen.
Yes, it's coming and it's on. The floor is yours.
Okay, perfect. All right, hi everybody. Warren Lazarus, as John so kindly introduced me. I'm based in Johannesburg, South Africa, currently working for Freedom One. We are a battery manufacturing and energy solutions company. So my expertise are currently in the battery energy storage systems, commonly known as BESS. Sometimes we might say that we are the best in the game. It's just a quick joke to start us off. I know there's a lot of information that's being shared here. So yeah, please stay with me. We'll get through it and yeah, we'll get some questions and some answers. So just to start us off, I want to thank FCA and John for allowing me to this opportunity to speak at the C conference. I hope I can provide some information and insight into the great things we do here at Freedom One. To kick this off, just want to pose a question to everyone. Why did the tree want to install panels on itself? Uh, because it wanted to be a power plant. So just to lighten the mood there, I hope that that joke can be used by yourselves. Anyway, let's get on to business. Today, I'm going to present on
Warren, I think
optimizing
your
battery
screen are
performance.
not moving. We're still on your
Okay.
front slides. Yeah.
Yeah, yeah. No, I'm just introducing myself.
Ah, sorry
We'll
about this.
get anyway, yeah, let me present. So today I'm presenting on optimizing battery performance and minimizing losses. So just an introduction. The following characteristics collectively determine the overall performance, reliability, and suitability of a battery for specific applications. So capacity is one of them, the first one. So I'm just going to give you brief descriptions of each one. The capacity of a battery refers to the amount of electrical charge it can store. It is typically measured in ampere hours or milliampere hours. And higher capacity batteries can store more energy and provide longer usage time. But as we get to bigger batteries, which we provide at Freedom One, we measure these capacities in kilowatt hours. as Nick mentioned earlier in his presentation. The biggest battery we have is about 1,500 kilowatt hours, so that's pretty big power. Yeah. So the second characteristic I'm going to dive into is voltage. This indicates electrical potential difference between positive and negative terminals of the battery. It determines the power output of the battery and is crucial for the operation of electronic devices. So I'm just going to continue to the chemistry of the battery. So different battery chemistries such as lithium ion, lead acid, nickel metal hydride, and others offer varying performances characteristics. Each chemistry has a unique energy density, charge, discharge rates, and cycle life, which we'll get into next. We at Freedom One, we use lithium iron phosphate. We are experienced in that, and we see that as a very good technology for batteries that we use. Number four, we go to cycle life. The number of charge and discharge cycles a battery can undergo while still retaining a certain percentage of its original capacity. A longer cycle life indicates better durability and longevity of the battery. We go to charge rate, the rate at which the battery can be charged without damaging its cells. Higher charge rates enable faster recharging, which is important for users' convenience. Then we go to the discharge rate, the rate at which a battery releases its stored energy. Batteries with higher discharge rates can provide more power for demanding applications. Temperature tolerance. So batteries perform optimally within a specific temperature ranges. Extreme temperatures can affect the battery performance and longevity of the battery. Number eight, self-discharge rates. Okay, so the rate at which a battery loses its charge when not in use. Low self-discharge rates are desirable for batteries intended for intermittent use. Then we go to number nine, safety features, built-in protection circuits, the normal thermal management systems, and other safety features contribute to overall performance and safety of the battery. At Freedom One, we incorporate a fuel system which is easily maintainable, and that's the safety feature that we use in our batteries. Number 10, so the environmental impact. So environmental considerations such as recyclability and the use of eco-friendly materials are increasingly important for evaluating battery performance. Okay, so I'll just take you to the next slide. So optimizing battery performance involves several strategies aimed at maximizing the battery's capacity, lifespan, and efficiency. Okay, go to the next one. Sorry. Okay, by implementing the following strategies, users can effectively optimize the performance and extend the lifespan of their batteries, thereby ensuring reliable and efficient operation for their devices. Okay, so optimizing battery performance involves several strategies which we are going to look at. So the first one I want to mention is proper charging. So if we use a correct charger designed for the specific battery chemistry uh, and voltage, we will be able to ensure proper charging of the battery. If proper charging is ensured, we avoid overcharging or deep discharging. So, as these can degrade the battery and or over time and would reduce the amount of cycles it can produce. So, temperature control is the next one. So, if we operate and store the battery within the recommended temperature range, this is to prevent performance degradation. This will help improve the battery's health, state of health, and it avoids exposing the battery to extreme heat or cold conditions. This will also help the battery's health in terms of the longevity of the battery usage. So avoid high discharge rates. minimize high current draw. So high inrush current usually affects the batteries. And so if we minimize that using VSDs and stuff for the load requirements, it helps with the life cycle of the battery. As this can put a lot of stress on the battery, as you can imagine, it reduces its lifespan. So, okay, proper charging. Uh, sorry, proper storage. Proper storage is the one. Storing, keep the battery clean and inspect it for physical damage or corrosion. Tighten any loose connections and ensure proper ventilation for heat dissipation. And proper storage, store the battery in a cool, dry place with moderate temperature. If storing for an extended period, ensure the battery is partially charged to avoid deep discharge. Use energy saving features. Utilize power saving settings on device to reduce unnecessary battery drain. Okay. 7, battery management system. So implement a robust BMS for lithium-ion batteries to monitor and control charging and discharging process, thus ensuring the safety and longevity of the battery, as previously mentioned by Muisa. Optimize device settings. So adjust device settings to reduce power and consumption, such as lowering screen brightness, disabling unused features, and just using power saving modes, which the battery comes with. Upgrade firmware and software. So keep the device firmware and software up to date, as manufacturers often release updates to optimize power management. This is critical for the batteries, because as manufacturers of the batteries, they tend to know exactly how they operate, and they have done studies on this. So number 10, choose the right battery for the right application. Select a battery with appropriate capacity, voltage, and chemistry for the specific application to ensure optimal performance for the backup energy system. Regular use. For rechargeable batteries, regular use and partial discharge cycles can help maintain the capacity. So on a weekly basis, we recommend that we discharge the battery up to 80% and then charge it fully, just so that we maintain it and it's in use. And this is just a way we have seen that it can help expand the lifespan of the battery. Recalibration, which Muisa dived into depth with. For devices with rechargeable batteries, periodic calibration can help the device accurately gauge the battery's capacity. So this just means that if we ensure the battery is fully charged at a minimum on a weekly basis, we can therefore have an more accurate description on the state of charge of the battery. So how can we implement all of these things? Because there's quite a few strategies that we spoke about. How can we implement all of these strategies for optimization of the battery via BMS? So a BMS played a crucial part in a role in optimizing the battery performance. Thus, the BMS also helps minimize losses in the battery. So it accomplishes this through several key functions and features, which we will discuss and dive deeper into. So besides from the BMS, there are other factors to minimize losses. Uh, these are taken into consideration during the design process of the actual battery itself and how it's constructed. So busbasizing, this is the interlinks between the cells to minimize IR losses. We have proper conductor cables used, and some instances using HV batteries, high voltage batteries. Higher volts means lower current. The less the IR losses are, makes it more efficient, primarily linked to the selection and design of the battery process. So we can use all of these things in designing the battery, and this this improves it in terms of the IR losses and the losses, minimizing losses in the batteries. So I'll just move on to optimizing battery performance using a BMS. So the first one is cell balancing. Okay, so cell balancing, the BMS does this. It monitors and balances the individual cells within a battery pack. So to ensure that all cells are charged and discharged evenly, this helps to maximize the usable capacity of the battery and prevents premature cell degradation. Number two, overcharge and over discharge protection. So the BMS prevents overcharging and over discharging of the battery, which are key factors that can significantly impact battery lifespan and performance. This safeguards ensures that the battery operates within the safe voltage limits and preserving its health for longer periods of time. So temperature monitoring and control can also optimize the battery performance. So the BMS does this by monitoring the temperature of the battery. The BMS can take preventative measures to avoid extreme temperatures that will if inevitably degrade the battery performance. It can also activate cooling or heating within the battery uh, so that the battery can function in an optimal temperature range. The next is the state of charge and the state of health monitoring, which I mentioned previously. So the BMS continuously monitors the state of charge and state of health of the battery, providing accurate information about the available energy and the overall health of the battery. This data is crucial for optimizing charging and discharging processes. Then go to the next slide. Safety features that the BMS has. Advanced BMS units include safety features such as short circuit protection, overcurrent protection, and cell voltage monitoring to ensure safe and reliable operation of the battery. As you know, these batteries can be dangerous if not monitored and also used in the right instances. So it's very imperative that a BMS is used. So the next point is efficient charging algorithms. So the BMS utilizes intelligent charging algorithms. This is to optimize the charging process, ensuring the battery is charged in a controlled and efficient manner, which contributes to its long-term performance and the cycles that it can format. Communication interface. So many BMS units provide a communication interface that allows a user to monitor all the battery's different parameters, receive alerts, and adjust settings, enabling proactive management of the battery system. So we at Freedom One we've recently added a remote monitoring so that we can communicate and interface with the battery remotely as we implement batteries across various landscapes. I would like to say very remote locations. So we've implemented that. Fault detection and diagnostics. The BMS can detect any and diagnose faults in the battery system, uh, enabling timely intervention and preventing potential issues that could impact performance and damages on the battery. So this is why a BMS is important in the use in the construction of a battery. So I'd like to end my presentation here, and I'd like to just welcome my colleague Isaac Komba, who he joined me for the Q&A. He's an expert in the field, so he's just going to be supporting me as well in this section.
Thank you very much, Warren. Yes, and Isaac, you can also please turn on your camera so we will welcome you and unmute yourself. So we will welcome you to address some of the questions from the audience. Welcome, Isaac.
Thanks, John.
If you don't mind, I would like to start with a personal question based on your presentation, Warren. At some point in the beginning of your presentation, you said one of the key factors is to use a charger that is adapted to the battery. Can there be can there be chargers that are not adapted to the battery? Maybe I'm a bit naive, but I thought the charger comes with the battery and by definition it's adapted to the battery.
Yes. So different charges are relative to different chemical compositions of the battery. So I will allow Isaac to explain further, but from my understanding is that we different charges go to different cells, and it charges the battery at different voltages. So the chemical composition determines the voltage of each cell, and that way is that's how we charge the batteries. It has to be at a certain voltage to charge each cell. So I'll let Isaac expand more on that. I see he had something to say on that.
Yeah, so in most cases, if you look at the lithium-ion battery chargers, they tend to actually have some BMS communication. So BMS communication sends some information to actually do the management of the charging of the battery. So there's certain limits that you send to a lithium-ion battery charger, whereby you look at your charge voltage limit, your charge current limit that you need to take into consideration because of the monitoring devices which are incorporated within the cell itself. So you're looking at your temperature detectors. If the battery sees that the internal temperature is too high, the temperature rise, then it starts limiting the charge current to protect the cells from reaching a higher temperature and thus actually limiting the cell degradation. Whereas those functions are not available on voltage-based charging chargers, which are mostly linked to your what do you call this? These cells, cells that they don't use the same chemistry as lithium ion, similar to your lead acid and so forth. And your gel batteries, they normally don't require BMS communication.
Thank you very much. We have the next question from somebody who did not share their name, but that's fine. So we'll say it's a question of the anonymous attendee. I'll read out the question. When we talk about batteries, for example, with 8,000 cycles during their lifetime, how do we account for partial charging and discharging in their cycle usage when you model for the battery lifetime?
Um,
So okay, yeah, you can go, Isaac.
Okay, so this varies depending on the battery manufacturer. So normally when you're looking at a cycle, you're looking from 100% to a specified DOD by the manufacturer and back to 100%. So that's how we count our cycles at Freedom One. That's a full cycle. So if we looking at a 80% DOD, so from 100 to 20% and back to 100, that's a full single cycle. So when you discharge to 50% and back to 100, then we make use of what we call microcycling. So we don't count that as a full cycle. We count that as a microcycle. So when you do two 50% DOD in terms of cycling your battery, then that will equate to a single cycle. So it varies depending on the type of manufacturer, the brand which you've purchased. Some brands actually, regardless of how you discharge your battery in terms of your depth of discharge, they still count that as a cycle, which also translates to the battery lifespan, and which in most cases is also linked to the warranty. So those are some of the things that you need to take into consideration as to how the battery manufacturer actually calculates their cycles.
So if I understood you correctly, thanks to the microcycles, you are actually if people count cycles like days, if there are days that they are drawing less from the batteries, they are actually increasing those number of days that they can use your batteries.
Correct, yes. I think the previous speaker actually had some form of presentation in terms of the depth of discharge. The less your depth of discharge, the more cycles you can have on your battery in terms of if we attribute each cycle, regardless of the depth of discharge as a single cycle, then you can actually prolong the longevity of the battery. So if a battery is made to last you for for 10 years on an average 80% DOD. If you do a 50% DOD, then you tend to expand its lifespan.
Still another question about cycles, and this is not a question which is being asked today, but this is a question that we regularly get in our interaction with professionals on a daily basis. You are continuously improving the quality and the number of cycles of your product, and I'm asking this question to you specifically because you manufacture products. People sometimes question, like, how can you know today that a battery you've just started producing will reach that many cycles because you've not had enough return of experience to actually see that? How does this get determined?
So there's a lot of testing that goes through, specifically for the cell manufacturer in terms of with new technology that comes into market. Some cells you can actually have a less form factor. You can reduce the form factor of the cell while also increasing the capacity. Remember, the number of cycles that you can put on a cell, it's not dependent on how long the battery you have it in terms of during the research and development phase. The number of cycles, depending on how many cycles you can, how many times you cycle the battery, actually determines the battery lifespan in years. So during the testing phase, you can discharge and charge the battery rapidly, as fast as you'd want it to be. So in a day, you can do maybe 100 cycles. And if you are able to achieve 8,000 cycles for that specific cell, then it translates to, if you use that specific cell to construct a battery, then those number of cells that you can achieve, cycles that you can achieve for that specific cell, then you can translate it to the number of cycles that a battery can actually have. So it comes in to play mostly in the research and development and testing of a particular cell, so which has a specific lifespan in terms of number of cycles that the battery can achieve and still be able to produce its capacity.
Thank you very much. Next question from Hafiz, specifically for lithium batteries. At some point in your presentation, you mentioned something about partial charging. And Hafiz is wondering how can partial charging prevent deep discharge of lithium batteries?
Okay.
Don't know who wants to take on that question.
All right. So I think that translates most into at the rate at which you actually charge your battery. Now, obviously, if you charge your battery at a lower C rating, then obviously that helps in terms of maintaining the battery longevity. And the degradation process that actually takes place, it's not as severe as when you actually charging the battery at a higher C rating. So when you utilizing partial charging, the losses also experienced in charging that particular cell is not as severe as when you actually charging at a higher continuous charge of battery, which translates to a higher current. And as long as you introduce higher current within a system, then Ohm's law will take effect, which is your IR losses that will, and those are mainly felt in terms of heat dissipation, which also affects the longevity of the cell. So if the system is sized correctly and it's charged at and discharged at a lower C rating, then you tend to actually um, um, help in terms of maintaining a high performance system in terms of the battery longevity and not exerting too much stress on the battery. Then it also helps in terms of increasing your battery lifespan as well.
Thank you. The next question we have from Okwu is directed to both of you, Warren and Lazarus. First of all, he wants to thank you very much for your presentation, but he would also like to hear about the implications of running highly inductive loads on lithium battery systems. And maybe you can first, for the listeners who might not know, if you can explain what a highly inductive load is, and then if there are any implications on lithium.
So when we look at highly inductive loads, it's basically your induction machines with a higher reactive power component, which actually exerts more stress on a system. And if you look at your power graph, it increases basically your apparent power demand. So in most cases, there are transient currents which the system will experience due to the high initial inrush currents that's required to actually power these machines, specifically during startup. So because in most cases, the battery is coupled to a hybrid inverter, so mainly those are felt by your inverter itself in terms of the impact load. It's felt by the inverter. The inverter has some limitation in terms of hardware, the IGBTs. There's a certain amount of current that they can handle. And as soon as it sees a rapid rise in power demand, what tends to happen is that voltage collapses. And when the voltage collapses, you have an increase in current. And that phenomenon causes the system to actually trip on overcurrent. And when that happens, then the inverter feels the impact load, and it tends to protect itself and shut down. So to actually compensate for that, in most of our applications, we recommend the incorporation of VSD drives, which actually help in reducing the transient current during startup of induction motors. So when looking at the battery side, if the battery is sized correctly, what it just needs to do is to provide the continuous discharge power. But in terms of those impact loads being transferred to the battery, they are mostly limited by the inverter capabilities.
Warren, I don't know if you have anything to add to this, but that sounded like a pretty
Yeah.
comprehensive answer to me.
Yeah, no. I think Isaac, he's our muscles on the tech side. So yeah, he's covered everything. If I could just add maybe on a high level to explain to everybody is that the inrush currents from the inductive loads are the ones that cause the tripping in the inverters. But as long as our batteries are specified and correctly specified for the system that it needs to back up and power, there shouldn't be an issue in terms of of the discharge rate.
Well, gentlemen, thank you so much. It's been a information-rich presentation. Thank you very much for your participation.